Section 1.4, Learning Chemistry, Key Math Skills. During your study of chemistry, you will work many problems that involve numbers. You will need various math skills and operations. We will review some key math skills that are particularly important for chemistry. As we move through the chapters, we'll also reinforce key math skills as they apply. A. Identifying place values. For any number, we can identify the place value of each of the digits in the number. These place values have names such as the ones place, the first one to the left of the decimal, tens, second to the left of the decimal. Now let's look at the place for a value of a number without a decimal point. 2,518, 2,000s, 500s, 110, 8 ones. Now we'll look at a number that has a decimal point. We'll identify place values such as the tens place, first place to the right, hundreds place, second to the right, 6.407, 6 ones, 4 tenths, 0 hundredths, 7 thousandths. B. Using positive and negative numbers in calculations. A positive number is any number that is greater than 0 and has a positive sign. Often the positive sign is understood and not written in front of the number. For example, the number positive 8 can be written as 8. A negative number is any number that is less than 0 and is written with a negative sign. For example, a negative 8 is written as negative 8. Multiplication division of positive and negative numbers. When two positive numbers and two negative numbers are not multiplied, the answer is positive. When a positive number and a negative number are multiplied, the answer is negative. The rules for the division of positive and negative numbers are the same as the rules for multiplication. When two positive numbers and two negative numbers are divided, the answer is positive. When a positive number and a negative number are divided, the answer is negative. Addition of positive and negative numbers. When positive numbers are added, the sign of the answer is positive. When negative numbers are added, the sign of the answer is negative. When a positive number and a negative number are added, the smaller number is subtracted from the larger number, and the result has the same sign as the larger number. Subtraction of positive and negative numbers. When two numbers are subtracted, change the sign of the numbers to be subtracted. Example, 12 minus positive 5 equals 12 minus 5, or 7. 12 minus a negative 5 is 12 plus 5, or 17. C. Calculating a percentage. To determine a percent, divide the parts of the total and multiply by 100. For example, if there are 8 chemistry books on the shelf that has a total of 32 books, what's the percent of chemistry books? 8 out of 32 times 100, which is 25%. When the value described as percent, it represents numbers of parts of an item in 100 of those items. If the percent of red balls is 5%, it means that 5 red balls out of every 100 balls. If the percent of blue balls is 50%, there are 50 blue balls in every 100 balls. Percentages as decimals. If you're given a percent such as 25%, it can be converted to a decimal. Number 1, write the percent value over 100, and then express the fraction as a decimal number. D. Solving equations. In chemistry, we use equations that express the relationship between certain variables. Let's look how we would solve x in the following equation. 2x plus 8 equals 14. The overall goal is to rearrange the items of the equation to obtain x on one side. Number 1, place all like terms on one side. The numbers 8 and 14 are like terms. To remove the 8 from the left side of the equation, we subtract 8. To keep a balance, we need to subtract 8 from the 14 on the other side. 2. Isolate the variable you need to solve for. In this problem, we obtain x by dividing both sides of the equation by 2. The value of x is the result of when 6 is divided by 2. 3. Check your answer. Check your answer by substituting your value for x back into the original equation. 2 times 3 plus 8 equals 6 plus 8 equals 14. The answer 3 is correct. Summary. To solve an equation for a particular variable, be sure to perform the same mathematical operations on both sides of the equation. If you eliminate a symbol or a number by subtracting, you need to subtract that same symbol or number on the opposite side. If you eliminate a symbol or number by adding, you need to add that same number on the opposite side. If you cancel a symbol by dividing, you need to divide both sides by that same symbol or number. If you cancel a symbol or number by multiplying, you need to multiply both sides of the same symbol or number. When we work with temperature, we may need to convert between degrees Celsius and degrees Fahrenheit using the following equation. Temperature Fahrenheit equals 1.8 times temperature of Celsius plus 32 degrees. To obtain an equation for converting degrees Fahrenheit to degrees Celsius, we subtract 32. To obtain Tc by itself, we divide both sides by 8. E. Interpreting a line graph. A line graph represents a relationship between two variables. These quantities are plotted along two perpendicular axes, which are the x-axis, horizontal, and y-axis, vertical. In the following graph, the volume of gas in a balloon is plotted against its temperature. Title. Look at the title. What does it tell you about the graph? The title indicates that the volume of a balloon was measured at different temperatures. Vertical axis. Look at the label of the numbers on the vertical axis, y. The label indicates that the volume of a balloon is measured in liters. The numbers, which are chosen to include the low and high measurements of the volume of a gas, are evenly spaced between 22 liters and 30 liters. Horizontal axis. The label on the horizontal or x-axis indicates the temperature of the balloon was measured in degrees Celsius. The numbers are measurements into Celsius temperature, which are evenly spaced from 0 to 100 degrees Celsius. Plots on the graph. Each point of the graph represents a volume in liters, which was measured at a specific temperature. When the points are connected, a straight line is obtained. Interpreting the line graph. From the line graph, we see that the volume of the gas increases as the temperature of the gas increases. This is called direct relationship. We now use the line graph to determine the volume at various temperatures. For example, suppose we want to know the volume of gas at 50 Celsius. We would start by finding 50 Celsius on the x-axis and then drawing a line up the line graph. From there, we could draw a horizontal line that intersects with the y-axis and read the volume where the line crosses the y-axis.